Hi everyone, this video is the continuation of conversion of one solid into another solid. We will be dealing with melting and recasting. If you consider a cylinder made up of certain metal and this cylinder is melted and recast into small cones. If you are asked to calculate the number of cones recasted, the entire volume of this cylinder is used to make the cones. So since entire volume is used to make cones or recast cones, you have to use the volume of cylinder and volume of cones to get the number of cones equal to, you draw a line. Whatever is getting recasted should be kept at denominator, volume of each cone, and the solid which is melting, its volume must be kept at numerator. This is the simple and important concept of melting and recasting. I'll show you the application of this concept in different types of sums where cylinder is getting converted into cone, cone is getting converted into sphere, a sphere is getting converted into cylinder. It is exercise 17.5. Look at this question number 14. An important question had come in ICC 2006. A vessel in the form of inverted cone is completely filled with water. Its height is 20 centimeter, height of the cone is given 20 centimeter. Diameter of the top portion is given 16.8 centimeter. Question says that two equal solids are submerged. Two equal solid cones are submerged. As a result, 1/3 of water from the vessel flows out. 1/3 of water flows out. Find the volume of each cone submerged. So volume of water flowing out is equivalent to volume of these two solid cones. So we use volume of two cones to calculate volume of each. Write on the dimension of inverted cone, big cone. Or you can write inverted. Height is given which is equals to 20 centimeter. Diameter is given which is equal to 16.8 centimeter. Get the radius 8.4 centimeter. These two are known dimensions. Now use the statement of the question. Condition of the question. Volume of two cones is equal to volume of water flows out. And since water is kept in conical vessel, 1/3 of volume of cone, because 1/3 of water is flowing out, it is kept in cone, so volume of cone 1/3. Write on the formula 1/3 pi r square into height. After writing the correct formula, you need to simplify it. 1 divides by 9 into 22/7. This is value of pi. Radius is 8.4, and height is 20. Remove decimals from these two numerators, add 10 at each denominator. Now simplify it. 0 cancels. 7, 1, 2 times 14, 3, 3 times 3, 4 times 12, 3, 2 times 3, 8 times. You should not be cancelling it because you have 10 at denominator. Substitution of decimal will be easier calculation. Volume of 2 cones equal to, you are left with 22, 4, 28 and 2 divides by 10. The numerator multiplies. 22 into 4 is 88, 88 into 2, 6176, multiplied by 28, 8 multiplied 6, 48, 4, 7 multiplied by 8, 56, 60, 6, 14, 12, 14, 15, 2, 3, add it up, 8, 2, 9, 4. So you write this multiplied value of 4, 9, 2, 8 divides by 10, which is equal to 492.8 centimeter cube. Volume of 2 cones submerged. Therefore, volume of each cone. The volume of 2 cones is 492.8. Volume of 1 cone you need to divide by 2. So which is equals to 246.4 centimeter cube. Important question, slightly different from melting and recasting. It had come and ICSC and I had left this question. So I felt this is an important one, you need to practice it. Now, melting and recasting. Question number 17. Watch it carefully, it's very simple. A solid metallic cylinder. You write cylinder. Of radius 14 centimeter, radius is 14 centimeter. Height is 21 centimeter. Melted, it is getting melted and recast into small cones. So you write cones here. Each of radius is given 3.5 centimeter. Height is given, which is equal to 3 centimeter. Question says that calculate the number of cones obtained. Number of cones obtained. Number of cones we need to calculate. So we follow the condition. Cylinder is melting into cones. How many small cones are obtained? So you write number of cones. Follow this simple step. Since we are finding number of cones, so we write the volume of cone as denominator. And the solid which is melting, keep it at numerator, volume of cylinder. And once you write this statement correctly, formula substitution, volume of cylinder is pi r squared into height, 1/3 pi r squared into height. Cancel pi from both numerator and denominator. Reciprocate it. 3 r squared into height divides by r squared into height. Once you cancel constant quantity pi, then simplify the formula and start substituting. Number of cones. 3 multiplied by radius of cylinder is 14. Because cylinder's volume is at numerator, height is 21. divides by radius is 3.5 and height is 3. After this, you just have to cancel, remove decimal from here, 10, remove decimal 10, 3 cancels, 7 2 times 14, 7 5 times 35, 7 2 times 14, 7 5 times 35, 5 2 times 10, 5 2 times 10. You are left with 2, 21, again 2. Multiply these values now. 2 multiplied by 2 is 4. 4 into 4 is 16. 21 multiplies by 16, 6, 12, 1, 2, 6, 3, 336 cones are obtained. Cones are obtained. Simple steps. Number of cones, keep the volume of cone at denominator. The solid which is melting, volume of that melting solid should be at numerator. And formula has to be written correctly. Look at this question number 19, which had come in ICSE. Question says that certain number of metallic cones, each of radius. So you have cones of radius 2 centimeter. Radius is 2 centimeter. Height 3 centimeter. Melted and recast into a sphere. Radius is given, which is equal to 6 centimeter. Question says that calculate number of cones. So number of cones equal to, we are finding cones, so its volume should be at denominator. Solid, volume of sphere. Follow these steps. Number of cones, keep it at denominator. Next solid, write its volume at numerator. 4 by 3 pi r cubed, 1 by 3 pi r square into height. Cancel pi, 3 cancels. 4 into radius of sphere is 6. Radius of cone is 2, and height is 3. Simplify this. 3 2 times 6. 2 cancels. 2 times. Multiply this. You get 72 cones. This portion is very, very important. If you are asked to calculate number of cones, its volume must be kept at denominator. Volume of next solid, you keep it at numerator. Question number 21 is an important question. Question says that surface area of metallic sphere. So you have sphere melted and recast into small spheres. Write on the dimensions now. Surface area is given, which is equal to 616 centimeter squared. Diameter of small spheres is given 33.5. Find radius. 3.5 divides by 2. Remove decimal 0. You can simplify this. 5 4 times 25, 7 times 35, 7 upon 4 centimeter. Leave it in fraction. Question says that calculate the number of small spheres. We do not know radius of big sphere. And surface area is given to calculate radius. 4 pi r squared equal to 616. 422 by 7 into radius square equals to 616. Cross multiplication, r square equals to 616 into 7 divides by 4 into 22. It is divisible by 11. 11 2 times 11 5 11 6 2 28 4 7 times r square equals to 49. R is equal to root 49. Square root of 49 is 7 centimeter. You know radius. You have to calculate small spheres. Number of small spheres. Volume of small sphere. You write at numerator. Next solid is volume of big sphere. Follow this simple step. Now substitute, which is equal to 4 by 3 pi r cube. 4 by 3 pi r cube. 4 by 3 pi, 4 by 3 pi cancels. Remember one more thing. You cannot calculate their radius because they have different value. Radius of big one we calculated 7. Small one is 3. 7 divides by 4. Reciprocate this. 7, 7, 7, 4, 4, 4 divides by 7, 7, 7. Cancel it. 16 into 6 is 64. 64 small spheres are obtained. So I have left few sums from the exercise. You can do question number 17. You can do number 19, 20. Similar question is there in example. You can look at example for question number 20 and solve it. Question number 22. Do these sums. And there are other sums also in the examples which had come in ISSC. So you can go through those sums also for melting and recasting. Please do practice. Thank you very much. Stay safe.